Okay, it's time to start talking about functions and methods. Now, we're not going to, for this video, we're not going to drill deep into methods. Functions are simply small chunks of code, reusable code inside your overall program. A method, for the programming logic people, we will talk about methods in great detail in a bit, but a method is basically a function within a class or an object. So I'm going to be using function, the term function throughout this video, but keep that in mind. Functions basically take chunks of code and make them available for other areas inside a program. A method is something we use in objects and classes, but kind of does the same thing. General, simplest definition of a method is a function inside a class. We'll talk about that in more detail. But before we go down and start really talking about functions, give some anecdotes, give you some metaphors, analogies, whatever. I love up close magicians. I am not a magician. I don't play around with that stuff. I guess my fingers are too big. I can't pull it off or anything like that. But I love talking to up close magicians. And one, they will never tell you their secrets. And they will tell you, if I just spent 6 months, a year, 2 years, 3 years practicing a technique, why would I give that away? They'll tell you it's not magic. They will tell you it's skill, but they're not going to give you that away. But if you begin to ask them questions, they will tell you a lot of the up close magic or illusion is built upon very basic other smaller pieces parts, right? So there might be a couple skills, maybe 50, 60 skills that don't seem connected, but they practice those skills. And then by combining those skills together, they can create these really cool up close personal magic. And that's what a function is. A function is we decompose the program and we make parts that we know we're going to reuse. We make them a function and then we can call upon those functions. Now, that may seem like a lot of work, but it's more work in the beginning than in the end, because once you build your functions, you can reuse them. And then you don't have to worry about what they're doing because you've already tested. So for example, let's say you're looking for the area of a circle. That might be a function that might be used quite often. I wouldn't want to copy and paste that over and over and over. So I would create the function and then call that particular function. Now, some rules of thumb about functions. First of all, this is a rule. Your function should only do one thing, right? But do that one thing really, really well. Does one thing. Now, that one thing may return a value. So say you send a value to that function, it returns a value back to you. Or it does something for you. You send it a value or you ask it to do something and maybe it prints to the screen. So rule one, a function does one thing, but it does that one thing really, really well. Now, a general rule of thumb with function is as you're decomposing, your function should be pretty efficient. You don't want your functions going over 30 lines of code. If your function is going over 30 lines of code, there's probably better ways to write it. Now, that's not a hard, fast rule, but there's probably better ways to write it. Or maybe you're doing too much in that function. If that function is doing too much, split it. Remember, we want that function to do one thing, but do that one thing really well. And if your code is getting very verbose inside the function, you're probably doing too much in there. So quick recap before I go up to my screen. Quick recap. We have a function does one thing, does it really, really well. Function should be pretty concise. You don't want to go over 30 lines, general rule of thumb in there. If your function is beginning to get too complex, it might be time to split that function. We make it into small manageable parts. We decompose it that we can call those functions at a later time or at different parts inside our program. By doing all this, we end up abstracting those functions. Those functions become part of something else that we don't have to worry about. And in subsequent videos, I will show you where we can put those functions so they're not even in our main program, the program that we're currently working on. So let's head up to my screen. I'm up on my screen and you might be thinking, Nick's really off the deep end here. We have the Google Earth map of the United States of America. I want to zoom into something that's really kind of cool here. I'm going to zoom into Kansas. And sorry if we're zooming in too fast. Look, this is a very interesting, I'll zoom in a little bit more. You see these circles, and a lot of times you have a square, and sometimes you have a bigger square, and then you have circles within these squares. Very common thing you'll see in aerial photos of Kansas. Even if you go a little bit west in Ohio and Indiana, you will tend to see this, but not to this degree. This is called pivotal irrigation. Basically, I'll zoom in just a little bit more here. You can't see it too much, but you see this white line here and this white line here. At the center of this circle is an irrigation machine. And this is the arm. And what happens is they pump water through this arm and through mechanisms and gears. This arm rotates around this big area. Now, if we really zoom in, you can see this is where like the homes are, where people live. This is their fields and things like that. And you're saying, what does this have to do with function? Well, what if I was to say how much area is being irrigated and how much area is not? If we draw a square and then we have a circle, we can, basically determine area of the circle by simple geometry, pi r square. We can determine the area of a square by just saying, multiplying two sides together if it's a rectangle or something like that. Most of the time it's going to be a square, but you can see in this particular case we have a rectangle. We could begin to just really subtract pieces out. Now, do I really care about the, pivotal irrigation? No, but it's a great example for some of the examples that I'm going to do with functions and methods. Again, if you're in programming logic, we're going to be talking about functions right now. Down the road, we'll talk about methods. If you're in other courses, the simplest definition is a function is inside a class. So we call it a method. A method is a function inside a class. So it's often part of that class. Programming logic, let's not worry about it. Let's go up to Replit and let's do some demonstrations. All right, here I am in Replit. And like I've said in previous videos, let's start small and let's build upon it. We want to find the area of the pivotal irrigation, and then we want to find squares and stuff like that. Let's just start with simple geometry. And what I have here, we're not going to do anything with squares yet. That will be in a follow-up video. I created a really bad program here. And this program basically calculates the area, the circumference of a circle, calculates the diameter of a circle, or actually two circles. And if we look at this code here, right, we'll start with this block of code here. What does this block of code do? Well, basically, I give it a diameter, and then it determines the radius of that circle, because radius is half of the diameter. And then we print some stuff out. We said the diameter of a circle with a diameter, blah, blah, blah. We'll see that in a second. The radius of circle with a diameter, blah, blah, blah. Here we calculate the area of that circle based upon radius and radius. Here we print out the area, then we figure out the circumference, then we print out the circumference. So we put a blank space in here. If I scroll down, we do that with a second circle. So now we have diameter 2. I'm not calling it second circle, but we have diameter 2, et cetera, et cetera. And down here is basically if I had a circle within a circle, how much space I'd be using. Not too worried about that right now. So I'm going to actually kind of pop that out. Also, I kind of want to have a bit of an introduction to this program. It says, hi from Bad Maine. That's the name of this program here. And then down here, I kind of want salutations. Bye from Bad Maine. You'll notice that I'm importing math up here. Throughout these videos, I'm going to be discussing what that import is. Boy, does it make a big difference. Now that we need to talk about it in a little bit more detail. Let's run this program, all right? And I'm just going to say Python over here in the Python shell, and Python bad main, py. And very quickly, it comes out with hi from bad main, the diameter of 2020, 2010. Here's the area of the circle is, 314, excuse me. And then we have our second circle here, blah, 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 blah. Well, this is really bad code. This is extremely bad code. What if I have 3 circles? What if I have 4 circles? What about when I start dealing with squares and rectangles and triangles? If I go back to my Google Earth, we kind of zoom around. Let's see. Oh, here's an interesting area. That's kind of a triangle there. If I want to. That looks like, so they didn't get a complete circle. So if I go back to my code, this is really ugly. It's poorly written. It's efficient. It's definitely going to run. I proved that, but it's poorly written. It's very hard coded. Nothing really seems to flow. So now what I'm going to do is forget about running code. I'm going to start building this code with a lot more flexibility using functions. So I'm going to, first I'm going to, flip over here. I'm going to add a new file. And this file, I'm going to call it circular formulas. So here is my Python file called circular formulas. I'm going to close this up again. I'm going to move this stuff just a little bit over here so we have a little bit more screen to work with. Now, yes, I'm going to be copying and pasting back and forth between one screen and another so you don't have to see me sitting here and typing. Saves time. I've already typed some things, so we're in good shape. Since I'm going to be doing a bunch of calculations associated with circles, I probably want to use pi. I know pi is inside the math library of Python. This is going to start making a lot more sense what libraries are and where they're coming from. So the first thing I'm going to do is I'm just going to import math. And that's going to afford me the ability in this particular video to use pi coming from Python. Now, I'm going to do a big copy and paste from one screen to another so I don't have to sit here and type. If you remember, I started this program with a print. You know what? Let me go back to it so we don't forget. If I look at bad code says print hi from bad main. Okay. This. You know what? I'm going to split the screen this way. All right, so I import math. I don't want to do this. I want to create a function that will do this for me. So maybe I can pass it different arguments and parameters, and we could use, and we'll talk about what arguments are versus parameters in a second. So I'm going to do a quick copy and paste. So I created a function here, and a function, we want that function to only do one thing, but do that one thing very well. If it's calculating something, if it needs to return something, we want it to do something very, very well. So I put some comments in here. You notice I don't have comments here. So I have this function called print hi. We have a parameter called name. I can pass it the parameter in what's called an argument. We'll do that later on. If I don't pass it anything, it's going to take the default value that I assigned it here. I'm allowed to assign parameters default values in my definition statement while we're using Python. I then have a bunch of comments here. I said, this is just going to be a formatted print of a program, and it doesn't return anything. Well, the parameter is name of the program, default to circles. It doesn't return anything. It's just going to do something for me. So a lot of our functions may not return anything back to us. They just do something for us. This is just going to print the program's name. Well, you know what? Since I have a print high, why don't I have a print by? Through the magic of cut and paste, I have a print by. It's going to follow the same logic here. I can send it a parameter, or I can default it a parameter of circle formulas. Formatted print of a program, parameter name is name, and it returns nothing. Now, before we go any further, I'm going to move this over to here now and back to the screen. And I want to run this program. Remember those small incremental steps from the beginning of the semester I talked about? You don't want to try to do too much all at once. So I'm going to say Python and circular formulas.py. Oh, I didn't call those definitions. I meant to do that. The old Pee-wee Herman, I meant to do that. So you know what? I need to go down here. Indentation's important in Python. And I'm going to say print hi. I'm not going to send it anything. And then print by. Again, not send anything. Anything I put into here is what's referred to as an argument. Up here in the definition, that's a parameter. If I run this, better run. And I have a misspelling. Now let me run this. So it says hi from circle formulas by. There's nothing in here, so it assumed this default value here. I could have easily sent it a value. I could have put an argument in here. This won't make sense, but I could have easily put a value in here. Now if I run this, you can see hi from Nick, bye from Detiro. But in this particular situation, I'm happy with it. It's just saying what this program is named. And again, in subsequent videos, this will make more sense. So I have my first two functions. Now, we want to plan our programs. We don't want to plan them in grandiose scales like I'm going to do this, 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 and this. I want to plan the overall overarching things. Now, when we're dealing with circle geometry, a lot of circle geometry is based upon the radius. The radius is half of the diameter, right? So we want to avoid a problem though. When do we use radius versus when do we use diameter? So when we're programming this, there may be a time that we want a function be called that requires the diameter. And then there may be other times that there's a function that will be called that requires the radius. Well, we as human beings and programmers, we don't want to make that decision. We want to make things as clean as possible for our end users. So I am going to make a decision here. It's a programming logic decision, but this is a decision. I'm going to say, whenever possible, always just send the diameter, right? I can say whenever possible, send the radius, but simplicity's sake, I'm going to say whenever possible, and I need to send an argument and then have the function used as a parameter, I'm always going to send it as the diameter, and I'll allow the functions to deal with it. I don't want to make that decision. So if I'm coming up with a rule of thumb in this program to always just, whenever possible, always send the diameter and let the functions worry about or deal with converting the diameter, radius, etc., etc. So let's create another function here. I've made the decision that I'm always going to pass the diameter. So now what I'm going to do is I'm going to create a function that takes the diameter, this little small d, takes the diameter and converts it into radius. Now, if you look here, now we're finally getting into a return. This function is going to return a value back to whoever called it. So the caller will say, I'm going to send you the diameter, send me back or return back the radius, right? It's a very simple function, and a lot of times these functions will be very simple, but it does the job. It does the job very efficiently. So you know what I'm going to do? I'm going to run this program, and I'm going to say radius is equal to the function get radius 20. So launch the function or call the function get radius, pass it the diameter of 20, and then put the result into radius. And if I just say print string radius, and now if I run this program, I'll clear the screen. And if I run the program, okay, hi from circle formulas, you know, the radius is 10. If you're giving me a diameter of 20, the radius is 10. What if I want to print this? Well, I'm printing it here. What if I wanted a cleaner print? Well, I could have functions that will do things for me that won't necessarily return values. We saw this up here with the print hi and print goodbye. So guess what? I'm going to create another function called print the radius. And you'll notice I'm still just sending it the diameter. That's my programming planning, where always just send the diameter. Always just send the diameter, right? What if for some reason you need to send the radius? We'll address that. But for our discussion, we're always just going to always send the diameter in this particular situation. Here are my comments. Format a printed radius of the circle. Parameter is D, that's here. You're not going to return anything because this is just a print statement. Now, I do have it calculating right here, calculating R, get the radius, very similar to what you saw me do down here. So I'm having one function call another function. So you can see the value already that pretty much every function that I'm setting up, if it needs the radius, I'm going to call the function get radius. And that's what I'm doing right here. So I'm going to send it whatever D that I sent it before, the diameter before, it's going to call this function, replace, and then put that value inside R and then print it out. So now if I go down here, let me clean this up a little bit. And I'm going to say print radius, and I'm going to send it the value of 20. Right? So I'm calling the function print radius. I send that a 20. It then takes that 20, it gets the radius from this formula here, this function here, and then it prints the radius here. And I've even cleaned up my formatting to make it look a little nice. And if I run this, hi from circle formula. The radius of a circle with a diameter of 20 is 10. That's not too bad. Now, if I get into multiple circles and I just want to start printing, let's say I want to see a circle of, if I print radius and let's say diameter is 10. You know what? Let's make the diameter 5, right? And again, if I run this, much easier. Instead of doing all these copy and pasting and even this copying this print statement, what if I need to make one slight adjustment here? I only need to make it in one place. All right. What's another interesting formula that we can get? How about getting the area of our circle? Well, do the magic of copy and pasting from one area, one screen to another. Let's take a look at this. It says definition, get area. Area of a circle. Parameter, we're still only passing the D. But this time we're going to return the area, right? So very efficient code. General rule of thumb, if your functions or methods start getting large, beyond 30, 40 characters, you're probably not doing it as best you can. You don't want your functions getting past a certain amount. You don't want them getting unwieldy. There's probably a good chance if you get to 30, you could probably split that function. I'm going to keep reiterating this, no pun intended. The function needs to do one thing, but do it really, really well. This function right here returns the area of a circle. The area of the circle is determined by pi r squared. So since I sent a diameter, first thing I'm going to do is I'm going to find the value of r. I'm going to get the radius. It's going to be put into r. And then I'm going to return the value back of pi times pi r squared. Sorry, pi r squared. Well, you know what? That might be something I want to print too. So how about we print area? Does the exact same thing. Not the exact same, but it's using the exact same concepts here. We're sending it diameter. We determine the radius based upon the diameter. Then we have a get area. Get area is based upon diameter, so we're sending it up to get area. We're always passing this print area now is calling two functions. One function gets the radius, the other function will get the area. And then I have this really nice little print thing saying the area of a circle with a diameter of whatever, a radius of whatever is the area. So let's print area. We're going to send it a diameter of 20. And let's run this. All right, screen's getting a little bit unwieldy here. Screen a little bit more. All right, so radius of a circle with a diameter of 20 is 10. The area of a circle with a diameter of 20, or the radius of 10, is 314.16. How about we look at some more? How about a circumference? You know, the length around that circle. Well, guess what? Let's get our functions going. So we're still passing it the diameter, and then this is going to return the circumference of a circle, parameter after, and you're going to return the circumference. First thing we need to do is call that get radius. So we're going to pass get radius, the diameter, and then we're going to return the circumference. Circumference is 2 pi r. So 2 times pi times r, and we return that. That might be a nice value to print. Oh, magic of cutting and pasting. All right, so let's take a look at this cut and paste. I'll stretch it out a little bit so it's easier to read. Definition or print circumference, format parameter is diameter, return nothing, just print something. First of all, calculate the r because it's easy, it's 2 pi r. Circumference, determine the circumference. So we pass it the diameter here, and then away we go. We sit there and print. So now we just say print circumference, and we pass it the same value of 20. So let's run this. Let me squeeze this over a little bit. And there we go. High from circular formulas, the radius of a circle, the area of a circle, the circumference of a circle. All of this is now calculated for us. Now, you're probably thinking, this is a lot of work. You did a lot of work here, Nick. Yeah, but I can reuse that code much more efficiently. Let's say I want all this information, but I want it associated with something that has a diameter of 5, right? So for clarity's sake, I'm going to put a blank line in there. And yes, I'm going to copy and paste this. And instead of 20, we'll do it as 5. All right? You're saying, Nick, you're still copying and pasting. But it's a lot cleaner than this. This is madness. This I can't reuse. Slide it over here. I really can't reuse any of this code. What if in other areas of the program I need some of this? Well, then I would have to recreate it. But by doing it this way, all of these things are now functions. And I can call them from this program. And in subsequent videos, I'm going to be calling them from other programs. So let's take a look here. Yeah. All right, let's run this. On the wrong screen there. And we'll clear it. And now we're going to run it. So it found me values for 2 circles. Now think about this. You're saying, boy, that just seems very, very complicated to get there. The complication's at the beginning, not at the end. These functions are running really smooth. These functions are really, really nice. And they're running very, very smooth. So I don't have to worry about these functions. Later on, subsequent videos, we're going to put them someplace else. I only have to worry about this code here. So by focusing on the functions early, later on, I can keep reusing them and not have to worry about them. They're abstract to me. I'm obfuscating them. Big word, meaning I don't care about. I'm kind of hiding them. My programming, the logic associated with my programming is below this line. That's it. It's below this line. Yeah, it's calling functions, right? So let's stop here. Covered a lot of stuff. We put a lot of functions in here for circular formulas. In the next video, I'm going to fast forward it a little bit. I'll create, before the video, I will create another program that deals with squares. And then we're going to start working with those. That being said, let's keep learning stuff.